Welcome to Lesson 2. Today you're going to learn how to evaluate a function using synthetic division. We haven't talked about synthetic division yet, but we are going to use that to help us to evaluate. And then in the next lesson we are actually going to divide polynomials using this technique. So our objectives are to practice using the technique of synthetic division in order to evaluate polynomials with that technique. If I look on Wikipedia, here's the definition of synthetic division. It says it is a method of performing polynomial long division with less writing and fewer calculations. And if you remember your previous lesson when you did long division to divide polynomials, that was quite a lot of detail, that was quite a lot of writing. So using synthetic division, understanding how to use that technique can save you a lot of time when you are trying to divide. So let me show you what I mean, how we're going to use it to evaluate. So in this situation, we have a function, and we want to evaluate it for f of negative 4. So in the past, what you would probably do is you would substitute negative 4 in for all your x's. So it would look something like this. That's a lot of math that you will have to do, and you certainly won't be able to do that in your head. You'll have to use your calculator. So we have something called synthetic division that will help to eliminate all that math that you have to do in your calculator. So let me show you how to get started. The way you do synthetic division is you always start with what you are substituting. And we are substituting in here this negative 4 in for all our x's. So I would write negative 4 out here to the left. Then I would create a bracket that looks something like this. And inside that bracket, I'm going to put all the coefficients of my terms, including my constant term. But here's the trick. I need to make sure that I have a coefficient for every single term, starting with the largest term, which right here, let me circle that, is x to the 4th. So I do have a term for x to the 4th, and that would be 1. And then if I go down, numerically, I should have an x to the 3rd term. But notice that I do not. I go from x to the 4th to x squared. And we do need to have an x to the 3rd term. So if we think about what it might be, it's probably 0 x to the 3rd. 0 x to the 3rd would just be 0, and therefore it's not written in our polynomial. But we do need to consider that we have a 0, we call that a placeholder, if we're missing a term. So let's go ahead and start writing those. I have a 1 with my x to the 4th term. We already established that we don't have an x to the 3rd term, so I would need to put in a 0 as a placeholder. For my x squared term, I have a negative 5, and it's very important to keep the sign with the coefficient. For my x term, my x to the 1, I have a positive 4, so I can write that in. And then my constant term on the end is 12. So a way to check yourself is to look at your highest degree, and it says 4, so I should have 5 terms here. I should have 4 x terms plus 1 constant term, and I do 1, 2, 3, 4 plus my constant term. Okay, the way that you do synthetic division is just a process of multiplying and adding over and over again. So what I like to do is put a little plus right here to remind me that whatever goes in here, I'm going to add to these numbers. I'm going to add down. The way we start is there's nothing initially in here, so we just continue down with this 1 and we write it down here. 1 plus nothing is 1. Then we multiply. So with this row here, we multiply it always times this negative 4. So 1 times negative 4 is negative 4. And we put it up here. So all of our multiplication then goes into this middle row, and then we add down. So I did the first step, and now we'll just repeat that step over and over again. So I'm going to add down. 0 plus negative 4 is negative 4. Now I'm going to multiply. Negative 4 times negative 4 is positive 16. And we start over again. I'm going to add down to get 11, and then I'm going to multiply negative 4 times 11 to get negative 44. And then we start the process again. 4 plus a negative 44 is a negative 40. And then if I multiply, I get a positive 160. And then my final step start the process again. I will go ahead and add down. So I will get 172. Now that number is a very important number. It's very significant because that is the number we would have gotten had we substituted the -4 in for all the x's and simplified. We would have got 172. But if you'll notice, I did that very quickly without my calculator in my head, and I was able to get 172 much easier than just plugging in. Let's try a couple more. Okay, so we have a similar situation here. We have our polynomial, and we have the term that we want to substitute in or evaluate for. So remember, you write that here on the outside, and you make a bracket. And then we put all the coefficients inside the bracket. Now let's make sure we have them in order. So we start with an x cubed term. That's 8. Do I have an x squared term? I do. Do I have an x term? I do. And do I have a coefficient term? I do. So I don't need a placeholder for this one. I can just write my terms in here. So we have an 8, a -2, +1, and a -4. Now I'll go ahead and draw my line underneath. And then I'll put some reminders for myself. So I'll put a plus here to know that I'm going to add down, and then a multiply here to know that I'm going to take that number and multiply it back times the 2. So remember that the first number drops down. Then we multiply. 2 times 8 is 16. We add down. Start over. Multiply 2 times 14, 28. We add down. We get 29. Now we start over. 2 times 29 is 58. We add down, and we get 54. And now I have my solution. When I evaluate this function for f of 2, I get an answer of 54. So this synthetic division is very helpful in learning and being able to evaluate a function, and it will be very helpful when we are dividing in the next lesson. Let's try one more before we go. In this situation, if we look at our function, you're going to evaluate it for 3 when f is 3, or when our x value is 3, sorry. But if we look at our function, we are again missing a term. We have x to the 4th, we are missing the x to the 3rd, we have x squared, and we have x. But we are also missing our coefficient. So let's go ahead and fill in 2 placeholders this time, one for the x cubed and one for the constant term on the end. So we start with 2. We need a 0 for the x cubed. We have a -8 with the x squared. We have a 6 with the x, and then we need a 0 for our constant term. If you don't plug in the placeholders, you'll get the wrong answer. So be very careful to do that. So remember, we're going to add down, and then we're going to multiply diagonally. So the first term comes straight down. That gives us something to multiply. 3 times 2 is 6. Add down, 0 plus 6 is 6. Start over. 3 times 6 is 18. We add down, we get 10. Start over once again. 3 times 10 is 30. When we add down, we get 36. And then we can start over again. And we get 78 when we multiply 3 times 36. Oops, we don't get 38. Sometimes you might have to use your calculator or check your math. 6 times 3 is 18. If we carry the 1, 3 times 3 is 9, plus 1 is 10. So we get 108. 0 plus 108 is just 108. But still much simpler than evaluating by substitution. So the answer to this last one is 108. If we evaluate this function for f of 3, we get 108. This is a nice way to introduce you to synthetic division. That concludes our lesson on synthetic division and evaluating a function. So at this time, you should be able to practice this technique by evaluating polynomials.